So this is section 9.2. We're actually jumping back to section 9.2. See, we've already graphed parabolas in vertex form and in standard form. That was 9.3 and 9.4, I think. Anyways, we're jumping back to 9.2. We're going to solve quadratic equations by graphing. So we already know how to graph. But if I ask you to solve a quadratic equation, I'm going to show you how to graph it and just look at the x-intercepts, which provide answers. Check it out. The first thing that you should write down in your notebook is these set of notes. These words mean the same thing. Answers, solutions, x-intercepts, roots, zeros, all those mean the same exact thing, all right? So if they ask you to find the x-intercept of this equation, how would you do that? Yeah, how do you find the x-intercept? Do you guys remember, to find the x-intercept, you set what? You set y equal to 0 and solve, right? So if I told you find the x-intercept of this quadratic trinomial equation, you would set the y equal to 0 and you would solve it, right? And we could all do that. Actually, we will do that in a little bit. But it's pretty much the same as asking you to solve x squared plus 4x plus 3 equals 0. That's an equation that we could solve, right? And if you did set y equal to 0, it would be that equation with equal to 0, but on the right side instead of the left side. So I just want to make it clear to you that finding the x-intercepts are the same thing as me asking you to solve it or me asking you to find the answers, right? Which are technically the same thing as asking you to find the roots or the zeros. It all means the same thing for you to solve it. Now, if it all means the same thing, what's the easiest thing to do to find the answers to this equation or to find the x-intercepts? So the easiest thing to do, obviously, is to type it into Desmos. Y equals x squared plus 4x plus 3. And then you get that parabola. And then all you have to do on Desmos is click on the location of where your parabola crosses the x-axis. And it'll appear the coordinate. It'll appear the coordinate. Therefore, you know your answers are x equals -3 and -1. Cool? Okay. Let's say that you didn't have Desmos. And let's say I asked you to find the x-intercepts, which is the same thing as solving. Then you could go back and use the skills we've learned in the past, like a standard form quadratic trinomial where the a value is 1. You could factor it and then split it and solve it. So you could put an x right there and an x right there. Why is that? Because x times x is x squared. And how do you do this? You think what times what is the c value that if you add together is the b value? So what times what is 3 that if you add together is 4? 1 and a 3, right? 1 times 3 is 3, and if you add those together, it's 4, correct? So if you were to solve it by saying, okay, x plus 1, that could be 0, x plus 3, that could be 0, you're going to get two answers, x equals -1 and x equals -3. So what are the solutions of this equation? -1 and -3. But then again, according to the notes that we just jotted down, what do solutions actually mean? They mean answers. They also mean x-intercepts. So if you graph it, again, you're going to find those same answers, x equals -3 and x equals -1. So the main point for today, the main message is for you to understand that all these words mean the same thing. Yeah? So here's a worksheet. And I want you to think about number 1. They are specifically asking us to solve by graphing. Okay, so I would not solve this by graphing. But since they say solve by graphing, let's go through the motions. What's the first step to graphing? You would find the vertex. How do you find the vertex? You go x equals -b over 2 times a. That's going to be negative parenthesis over 2 times parenthesis. The b value happens to be -5. And the a value happens to be a 1 in front of the x squared because there's no number. So x is going to equal +5 over 2, which is 2.5. That's nasty, right? 2.5 is your x value. You have to plug it in to find your y values. Like if you did, see at this point, I would just stop right there. I wouldn't even do this. I wouldn't even try to solve by graphing. But just because they said I'm going to plug it in, the original says x squared minus 5x plus 6. But instead of equaling 0, I'm going to pretend that it says y equals. That way I could find my y value of the vertex by plugging in the answer that I just found, which was 2.5. Like I said, normally I wouldn't do this. I'd be like, forget this. I want to do it a different way. But anyways, if I did go 2.5 squared, that's where the calculator comes in handy. 2.5 to the second power is 6.25. Take away 5 times 2.5 is 12.5 plus 6. So when I go 6.25, take away 12.5, that's negative negative 6.25. And then negative 6.25 plus 6, that'll be a negative 0.25. Like I said, I would not graph this to try to find answers. Negative 0.25. So this is a disgusting, absolute disgusting vertex. Let's go to the location 2.5 on the x, negative 0.25 on the y. So 1, 2, 0.5 on the x is right there, halfway between 2 and 3, halfway. And down 0.25, 25 cents is a quarter, so that's a quarter of the way down. That's half of the half. So not even halfway, but only half of the half right here. Does that make sense? Everybody go to that dot, that nasty vertex, and put a dot right there. Right there. Again, that's 2.5 on the x and only a fourth of the way down. That's not even halfway. That's only half of the half right there. Now, we do know that there's an axis of symmetry right through there. Now, we could use the pattern 1, 1, 2, 4, 3, 9 because the a value is a positive 1. But look how ugly that'll be. If I go from this point, kind of like in the middle of different values, 1 to the right, it would be right here at that halfway point. And then I'd have to go 1 up, which would be up here to the 1/4 of the way down from the next nice value. Does that make sense? So how about this? Don't even do this. Just watch me because this is getting ugly. And then I'm going to go back to the vertex and I would go 2, 4. 1 to this spot, 2 to that spot, and then 4 up. 1 to that spot, 2, 3, 4 right there. Disgusting, right? Right there. Not even on nice coordinates. And 3, 9, 3, 9, I want to be off the graph, so I'm not even going to bother with that last one. I could map them over to the other side. That is halfway and halfway. So halfway and halfway would be right there. And then this one, 1 unit, 2 units, 1 unit to that halfway point, 2 units to that halfway point. This is really, really gross. Wait, did I do that right? Let me double check that. Okay, so half, 1, and another half. Half, 1, and another half. Yeah, right there. So anyways, there's our parabola, but the whole purpose of graphing was to find the answers, to find the solutions, which are the same thing as finding the x-intercepts. And I know that, I don't know exactly where it crosses. I know it's going to be somewhere here and somewhere there. My best guess is that value and that value. So it looks like 2 and 3, right? 2 and 3. So in order for us to actually verify that, we should probably go to an input-output table and actually plug in a 2 and a 3. So if I did plug in a 2 for the x, that'd be a 2 right there. 4 times 2 right here. I mean, not 4 times 2, but a 2 right here would give you a 4. 5 times 2 is 10. 4 take away 10 is negative 6. Negative 6 plus 6 is 0. And that is great because that does tell us the coordinate 2, 0 is right there. That's the x-intercept. That means that the answer is x equals 2 so far. And I'm also going to test the point 1, 2, 3, and hopefully it gives me an output of 0. That way I get that location, which is the x-intercept, which will be the solution, x equals 3. So if I do try to plug in 3 right there, 3 squared is 9, 5 times 3 is 15, 9 minus 15 is negative 6, negative 6 plus 6 is 0. So this also worked. So there's my other nice point. So since I'm looking for my x-intercept values, it would be these two, which is x equals 2 and x equals 3. Was that fun? I don't know. Maybe if you're bored on Saturday night, sure. But right now in class, we want to be more efficient. So what's the easiest way to find the answers to this guy? Well, it's either using factoring methods or using Desmos. Because look at this, was disgusting with all these coordinates and stuff. So one option is to graph it on Desmos. It's kind of messed up, I apologize. There's my equation, I graphed it, and you see right there that it intersects at 2 and at 3. Those are our answers, 2 and 3. Or if you didn't have a graphing calculator or Desmos, you could factor, split, and solve. So knowing that there's no number in front of x squared, you could set this up and think what times what is a c value, 6, that if you combine together is a b value, -5. That'll be a -3 times a -2. If you multiply those together, it does give you a +6. And if you combine them, it does give you a -5. So now that you have something times something equals 0, you could split them and set them each equal to 0. So if I did do that, x minus 3 equals 0, x minus 2 equals 0, you get your two answers, x equals 3 and x equals 2. So the question was, could we use Desmos to find the solutions, to find the x-intercepts, to find the answers, the roots, the zeros, whatever you want to call them, because they all mean the same thing. And I want to say yes, especially on this worksheet, I want you to use Desmos to save time, right? So before we move on other questions on this worksheet, let's jump over here. Just again, to reiterate, these words mean the same thing: answers, solutions, x-intercepts, roots, zeros. Now, I kind of showed you how x-intercepts mean answers and solutions, but how about roots or zeros? Where do those come from? Well, what if I asked you to find the solutions to this guy? What would you do to start finding the answers to that guy? You would add 9 to both sides, right? Actually, let me do this. I'm going to copy it and bring it down here. That's not working. Why is it not? Okay, there it is. Sorry about that. So if I did ask you to solve this, you guys just told me that you would set it equal to 0. So you would add 9, and you would have x squared plus 6x plus 9 equals 0. And by the way, that's one of the reasons why they have zeros as a possible word for this. Because you're finding the zeros, well, you had to set it equal to 0 first to find the answers. That's why they're called zeros. Why are they called roots? Well, if I continued to solve this and I think about factoring, I would be thinking, what times what is the c value 9 that if I add together is a middle value 6? What would it be? Obviously, x, and yeah, you said it. 3 times 3 would give you a 9, and if you add it together, it gives you 6, right? Now, if it equals 0, now instead of splitting and solving, which I normally would do, I could recognize that you have a binomial and the same exact binomial being multiplied with itself twice. So you could rewrite it like this: x plus 3 squared equals 0. And then you could solve it by getting rid of the square by applying what? A square root. That's why they're also called roots. Okay? So I could say find the zeros. What does that mean? Well, why would they even call it zeros? Why don't they just say find the answers? Well, because you got equal 0. You had to get it equal to 0 before even thinking about the zero product property. Why would they say find the roots if they could just say find the answers? Well, because sometimes to get rid of a square, you apply a square root, right? And if we kept going over here, you'd have x plus 3 equals the square root of 0, 0. Subtract 3, x equals -3. Cool? We could solve this guy by finding the x-intercepts. If I plug this into Desmos, but first move the 9 over, setting it equal to 0, then you'll see that the parabola crosses the x-axis where? -3. Now that's kind of weird because normally you would think of a parabola crossing the x-axis at how many places? 2, right? Because let's say, give me a second, let me make this all smaller. Let's say I had my xy plane like this, and I have a parabola opening up. You would think, oh, it crosses right there and right there. You would look for 2 answers, right? Now, if there's only one answer to this problem, what does that mean? That means that it only touches at one location. Maybe the parabola just touches right there. Well, technically, it should be over here at -3, touching at -3, because the answer is x equals -3, right? But so sometimes you will have 2 answers, like on this red parabola. Sometimes you'll have one answer, like on this one that just touches at -3. Sometimes you may have no solution, like if your parabola doesn't cross the x-axis at all, it'd be a no solution problem. Cool? Well, there's no real answers, at least. There are imaginary, but we'll get to that later. Let's go back to the worksheet. And again, I would like you to do 6 questions today. These 6 questions, and I would like you to use Desmos so you can get comfortable with it. It's kind of pointless to graph by hand when we've got Desmos. So if you go to this guy and you were to graph it on Desmos, I want to pause it. I want you guys to do it right now. Take out Desmos. I want to pause it. You guys do it, and then let's talk about the answer. When you're typing it into Desmos, obviously we're used to X's and Y's. So what you would do on Desmos is just say y equals x squared plus 6x plus 9. It should produce a parabola that opens up, that has a pattern 1, 1, 2, 4, 3, 9. And you should be able to see where it crosses the x-axis, if it crosses the x-axis. If it crosses at 2 locations, those 2 locations are your answers. If it only touches at 1 location, there's only 1 solution, only 1 answer. If it doesn't cross at all, then you would say no real solutions. If you type it in like this, instead of w squared, y equals x squared plus 6x instead of 6w plus 9, you will see that it produces this parabola. And if you zoom in, you'll be able to see where it crosses exactly. And if you click that button, it'll give you the coordinate -3, 0. So the x-intercept is -3. That means that the answer to this guy is -3. Make sense? So the answer to this guy is w equals -3. Because that's where it crosses if you graph it. Okay? So hopefully you guys could now try this next one. B squared minus 3b plus 4. And of course, when you use Desmos, I would type it in as y equals x squared minus 3x plus 4. Graph it, and then state your x-intercepts, which are your solutions, right? Which are your answers to this equation. But instead, you would say b equals wherever those locations are at on the x-axis. Go for it. Try it. I want to pause it. So if you typed it in correctly, instead of b's or x's or w's, you do x squared, right? Y equals x squared minus 3x plus 4. And then if you look at your parabola that it produces, and you'll see, wait a minute, it doesn't cross the x-axis. So if I know that where it touches the x-axis, those are my answers. Like if it would cross at 1 and 3, I would say x equals 1, x equals 3. Right here, it doesn't cross the x-axis. So what do you say your answers are? There are no answers, at least no real answers. They're imaginary answers. And we'll get to those later. But right now, you would just say no solution on this problem, okay? So it's important to understand that you could have 2 answers, 1 answer if it touches, or no answers, right? No real answers. Now, not all of the answers are going to be nice. If we go to these guys down here, like let's say I wanted to graph this guy. How would I graph it on Desmos? How am I going to type it in first? Y equals x squared plus 4x. Do I put equals 3? See, the thing is, it would be nice to set it equal to 0 first, right? Yeah. And then that would make it a 0 on this side, which is where the y comes from. So yeah, -3 would be your last value. So if you type this in, your standard form quadratic trinomial, that's set equal to 0, but you put a y instead of 0, you have your function, and you'll be able to see how it graphs, okay? I actually typed it into Desmos already for us, and check it out. If we were to graph it, it crosses at some nasty locations, right? So it's between -4 and -5. And over here, it's between 0 and 1. And on the instructions on this section, it says, solve each equation by graphing. If integral roots cannot be found, that means if nice numbers can't be found as answers, estimate the roots, estimate the answers to the nearest tenths, okay? So right here, you would say it's about -4.6, right? And also, x equals about 0.6, right? So those are your answers, más o menos. But later on, we're going to be able to get specific answers by writing them as radicals. Like the square root of 8 is a crazy decimal, but we're going to leave it as a square root of 8 instead of the decimal. Anyways, right now I just want you to practice using Desmos and finish up the last 2 on this worksheet, and we'll be done for the day. Tomorrow, we're going to learn about the quadratic formula, and we'll be able to find those nasty x-intercepts that are at crazy decimals, but using square roots. So in summary, this lesson, you want to know that answers mean the same thing as solutions, as x-intercepts, as zeros, as roots. All those mean the same thing. And you don't have to solve algebraically anymore. You could graph it on Desmos. Now, this is a very important part. In order to graph on Desmos, you have to first make sure your equation is set equal to 0. So if you want to take some notes down, write that down. Set equation equal to 0. Now, you see right here it says equals -7. You don't want that. So we need to get rid of that -7, set it equal to 0 by doing the opposite, +7 plus 7. So what we have here is 2v squared plus 8v plus 7 equals 0. Now, instead of writing the equals 0, you want to put it in terms of a xy function. So what you would do is rewrite this guy as, instead of equals 0, you would say y equals instead of equals 0, but you put it on the left side. And instead of 2v squared, you're going to put 2x squared plus 8x plus 7. And now this is ready to go, okay? So once again, to reiterate, how do you graph this on Desmos? First, set the equation equal to 0, move that over. And then after that, replace the equals 0 with the y equals in the front. So you're not going to write the equals 0 anymore. You're going to write y equals that junk. Put it on Desmos. It's going to be opening up and see where it crosses the x-axis. And if it crosses at 2 locations, you write down both locations. Those are both your answers. You would say v equals both of those answers. If it only touches it at one spot, then you would say v equals that one answer. If it doesn't cross at all, you would say no solution, right? Because there's no real answers. And I know that on these last 3, on 6, 5, and 4, you're going to have to do decimal approximations.